All right, so on any given day throughout the world, there are 455,000 airplanes that fly.
No way.
So, is it good enough that 99.9% of them make it safely?
No.
Because that would mean that
How many people are on the plane?
that means that 455 of those airplanes crash. So is the 99.9% good enough to say it's 100%?
So I assume you're not rounding up.
I don't round. But I do make sure that your opportunities don't allow you to be at that 0.9 or the 0.8 or the 0.7.
But doesn't the grid book like automatically round up there?
No, I turn that feature off.
What? Oh my god. I just really
You guys buy anything I say, don't you?
No, there's not.
All right.
You told me that that's the name.
All right.
Teacher.
Don't you worry. You will all earn the grade that you deserve to earn. Okay?
Who's that for?
What are things that I look for? What are things that I look for the kid who's sitting at the 78.7? I go back and look at that 78.7 pretty seriously, thinking, did I make an error on a test or quiz? And it's very possible I did. So then I sit there and there's things I look at. Did that kid turn in almost all the homework? No, they didn't. Well, it looks like a C.
So I better start turning.
Luckily, I'm good at that.
All right, so let's talk about this. This is one of the pages from yesterday's.
Can we go to the one before this?
Well, this is going to feed into it. This will feed into it, I promise you. Right. All right. So it says a dog breeder needs to create a pen. Oh, we passed homework forward?
Yeah.
That's it?
We didn't.
Right.
Mr. Sir, we didn't finish one of them.
On the homework yesterday?
Not on the homework, on the notes. Yeah.
I know. There's a couple of ones that I'm going to go back and kind of backfill. There's some that I'm skipping, but because I can backfill it, it'll answer those questions, and it'll help you answer the second page on Q.
How do you do the whole thing?
Well, I'm going to get there. All right. So, a dog breeder needs to create a pen with 5 runs for new litters of puppies. Okay, so let's just make sure we understand the context of this problem. I'm going to pull up the calculator.
Why does pen matter?
It just so you know, it's from the.
All right. So, do we understand what this is meaning? This means that we are going to create ourselves 2, 3, 4, 5. We have, let's just pretend I can draw really well. We have 3 areas that we're going to put these puppies. There are 5 equally sized pens. Is that okay?
Yeah.
We went over to the Harbor Freight or wherever we're buying our fencing, but there's 900 feet of this fencing. So if I add up all of these regions, my fencing will be a total of 900 feet. So does everyone comprehend what's going on with this?
Yeah.
Is anyone stuck? Okay. Is everyone okay with my drawing? I know it's not artistically perfect, but let's just pretend. Okay. So we have 5 pens. 1, 2, 3, 4, and 5. We good? All right. So let's start working through this problem. Well, I'm going to start calling the width. I'm going to call it X. Is that okay?
C.
So if I call that X, I'll call this X, 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 and X. So I have 1, 2, 3, 4, 5, total of 6 X's. Do you agree? Excellent.
Wait, why isn't it 7?
We'll count them.
1, 2, 3. You didn't do X actually.
So I have 1, 2, 3, 4, 5, 6 X's. Those are all of the widths. Is that okay? I also know that this is the length all the way here, right? So let's think about perimeter of fence. Perimeter is equal to 2L plus 2W. Agree? That was something you learned way back in elementary school. This is kind of an equation that's just there. All right, so let's do this. I know that I'm going to plug in right here. I'm going to plug in 6x. Those are my w's. Are we clear? Okay, so then I know this. So I have 900 is equal to 2L plus 12x. Is that okay? So now I want to figure out how to solve this equation in terms of, I want to know what L is equal to in terms of x. Okay? So that's a tougher draw to do right there. So I want to get L by itself. So I'm going to say that 900 minus 12x divided by 2 is equal to L. So let me pause there for a minute. Does everyone comprehend? How did I get that plus 12x? Well, I moved it over to make it negative 12x. How did I get the 2 in the denominator? Well, I wanted L alone, and 2 and L are being multiplied together. Then I can reduce this, and I can say, well, I know that L is equal to 450 minus 6x. Okay? So I guess technically, then I could plug that in and say, oh, I have this. Now, let's see who paid attention in Algebra 1. Is that equation there, 900 equals 2, quantity 450 minus 6x plus 2 times 6x, is that linear or quadratic?
Quadratic. No, linear.
Why is it linear?
Because there's no x.
Because there's no x squared. Okay? So, what other equation of a rectangle do I know that would be a quadratic if we multiply things together? Not volume. Go with area. Area is 2-dimensional, volume is 3. All right, so if I wanted to find the area of the rectangle, I know the area of a rectangle is length times width. Agree? So then I'm going to take my length. I found my length to be 450 minus 6x. And my width, what's my width? What do we call it?
12.
Well, I have W equals X, so my width must be X. If I multiply those together, does it become a quadratic?
Yeah.
Absolutely.
Oh, and then you can do factoring.
I'm not factoring.
No,
I'm going to graph it. Where are you lost?
well,
Wait, isn't the width
everywhere.
6x?
That's how you got that.
Okay,
I didn't put.
so think about the entire rectangle, length times width, right? Let's not worry about all those X's in there. We actually have those all built in right here. Okay? Does that make sense so far? So length, L, we found L to equal this. Width is just X. Yes, I understand I have multiple pens, but we have that embedded with the 6X right here. Does that make sense? All right, so now I want to graph it on the calculator. Okay? So I get 450 minus 6x.
Wait, how did you take the 2 out?
Hang on, 450 minus 6x times x. Is that what it was? All right, I'm going back right here. Where are you looking?
Oh, like in the one on the left that's boxed. Like, how did you take the 2 out?
This one right here?
Yeah.
So this is a perimeter equation, but I'm not looking for a perimeter. I had to use the perimeter equation to kind of figure out what L was in terms of x.
Okay.
So I used the perimeter equation here because I knew I had 900 feet. I know 2L plus 12x were what's equal to the perimeter. So if I were to add this length and this length, there's 2L's, and then I have 6X's. So 2L, the reason it's 12X is because I go 2 times the width. The width I found was 6X. So then I had to use this linear component to solve it for the length. So I'm using the linear component to solve for the length. So now I have a length here in terms of x that I'm going to use in my area equation. Area equals length times width. So then I get 450 minus 6x times x. Keep them grouped. It's going to make a parabola. Okay? All right, so this is plugged in. That's our same equation there. Agreed? So there's a few features on the calculator that you might want to use, but then once you use it, you want to adjust your window. It won't always show everything. So I'm going to go to the zoom, and we haven't done this one yet, but it's actually zoom 0, which is zoom fit. And that gives you a little bit of the parabola to look at. There's quite a bit I'm actually seeing, but there's stuff that's down on the right, on the bottom, I don't really need. So now I'm going to go adjust my window. Okay? So I'm going from -10 to 300. Well, let's look at our graph again. Do I really need to go all the way out to 300? Okay? I don't know. Let's maybe cut that down to 100. Okay? So I'm going to go in this direction down to 100. And I have a y minimum of -405,000. Do you think I'm going to get any negative lengths in here? Now, let's take this down to like -5. Okay? A y maximum of 8435. Oh, I have no idea. Let's just take a look at what our graph's going to look like. Well, that looks a hell of a lot better than what we just looked at. Agree? Okay. Is my vertex a maximum or a minimum? Does everyone agree with that? So I'm going to now go second, calculate. I want to find my maximum value. I'm going to go to the left side of it, enter, and then I'm going to go to the right side of it. Enter. So basically, if I have a width of 37.5 feet, so those are my x values, that will allow me to have a maximum area of 8,437.5 total area. Okay, so let me just write this down for a moment. I got 37.5, comma, 8437.5. Okay, so that's good context for us on this problem. All right, so let me scroll down here. Okay, what dimension should we use for the entire pen? I should have a width of 37.5. Okay? What is width is equal to x, agree? Okay? How can I find my length? Well, what's length equal to? Okay, you got a calculator? Do that for me real quick. What is 6 times 37.5? Whatever that answer is, what's 450 minus 6 times 37.5?
What is it? 175.
175?
6 times 37.5 is 175.
So go 450 minus 6 times 37.5. And 175 is what we're getting an answer from? Okay?
Hold up. 6 times 37.5, I got 225. Yeah.
Okay, and 450 minus 225?
Well, yeah.
Right?
Oh, 450.
450 minus,
325. Yeah.
it's 325?
Yeah.
450 minus 6 times 37.5.
So 6 times 37.5 is 225. 225.
That's 225.
And then 550 minus 2.
450 minus that.
450. So it's 225.
225?
7.
Okay? All right. Now, let's think. How much fencing do I have?
900 feet.
900 feet. Okay, ready? Well, if you have a calculator, do this for me real quick. 225 plus 225. Stop.
500.
You good? How many widths of 37.5 did I have for my original drawing?
6.
What's 6 times 37.5? 225? So 225 and 225 plus
225.
Yeah, 225.
225 times 2 is 450 plus 6 times 37.5 is 225.
so what is this math? What is that multiply to? Just tell me.
225.
225?
It's just 225.
Are we good?
What?
We did what?
Nothing. Just yes, you're correct.
Okay. How much would each run be? Okay. Well, this is going to be 5 equal lengths. Agreed? How much was my length?
450.
225 divided by 5.
25.
45? And my x that we just solved was 37.5. So if you created that, so each of these x's, 37.5, 37.5, 37.5, 37.5, 37.5, 37.5, and then all those 45s and all these 45s, that will give us our 900 feet. Now some of you are like, wait a minute, where's all that coming from? Well, you know there's 45s down here too, right? So that's 90, 90, 90, 90, 90. So 90 times 5 is 450. 450 added to 37.5, 37.5, 37.5, 37.5, 37.5, 37.5 will give us our 900. Okay? How big will each one? We got it. We added it, listed up the top.
47.5 times 45.
Okay, I'm going to move on.
I just don't.
So what you're doing, this is actually a really good pre-calculus that moves into calculus term with you're solving your dimensions for a variable. You're solving, for the most part, for x. That's all it is. Okay? All right. This goes along with our very last problem. So let's see if we can walk through this problem. I'm going to go to my last slide, and it talks about a store selling 400 coffees. Does this really apply to you? I've seen a lot of you walking around with these syrupy drinks from Starbucks that you pay anywhere from $4 to $8 for. Correct? So Starbucks has a price point that they figured out what is the ideal thing. Now, some people will say, oh, it's better to serve more people for less money. No, I'd like to serve less people and make more money because your inventory,
Less effort.
yeah. I mean, if you're able to serve 400 people and maximize your profits for the day versus serving 1,200 people, and you actually make less serving 1,200 if you don't have your price point right, then you do 400. So that's what this type of event is. So as a store sells 400 coffees per day at a cost of $1.50 each. I understand that's not Starbucks' motto. Okay, can't get anything for $1.50 at Starbucks. $10. Right? I understand, but I'm just trying to justify that y'all don't pay that. I've yet to see a high school kid go into Starbucks and order a black coffee, no
No
room.
cream, no sugar.
Okay, that's how I order. That's me.
Ew.
I'm that guy.
Starbucks black coffee's gross. Like,
Well,
it's not good.
It's an
I
acquired.
decaf, too.
You're also getting the advice from somebody who used to drink the water out of the gutter in Arizona. So
Ew.
I love that for you.
Nasty.
I drink
Okay.
motor oil.
won't hurt you.
I like my.
All right. So everyone comprehends that this store sells $400 or 400 coffees for $1.50 each. So let's just do this math. You all have your calculator still. So I would have some sort of profit of 400 times $1.50, and I think if I do that math, I come out to $600. Just double check. 400 times $1.50, is it 600? So right now, this company is making $600 a day selling these coffees. Okay, is that a great thing? We're not trying to get into the absolute real life crunching data on McDonald's or Starbucks or anybody else. We're just looking at a factual number. Okay.
I mean, they could go.
No, I'm not. No, let's not debate it. We're working through a problem. You want real life? Go find it out there. I'm just trying to give you something that's realization that you can do. Okay? I'm not trying to harp on you, but don't try and decipher what the heck's, can we envision $600? Yes, I think we can. Good. Move on. All right. From there, they've hired some firm, or maybe they're a conglomerate or everything, said, hey, we found that if we raise the price 10 cents, so it's now $1.60 a cup, we're going to get 40 fewer customers that come in. You with me? Okay. They also found if we lower the price 10 cents, you will have 40 more people come in. So then you'd have 440 people come in versus 360 people come in. You get the gist of it? Okay, so it's either increasing or decreasing. Do people change their habits based on price? Yes. Okay? It is a real life application out there. So, we are going to go back to this equation right here, and we're going to do the number original sold. How many did I originally sell? 400. Minus my sales decrease. Okay? So let's figure out all this. Sales decrease was 10 cents. Or wait, sales decrease. Number, I sold 400. I will lose how many if I increase my price by 10 cents?
40.
Times X. That's in parentheses, stop. Is that okay? And we're just plugging into this equation. Times the original price. The original price was $1.50, agree? Plus our price increase. Yes? So our price increase, how much did we increase our price by? 10 cents. 10 cents is 0.10, agree? Times X. Okay? So I have 400 minus 40x, $1.50 plus 10.10x. We're going to plot that. This is going to give us a parabola again. How do we know it's going to give us a parabola? Because we have an x and an x that are being multiplied together. It's going to give me a parabola that opens down because I have a negative 40x times a 0.1x. Agreed? So let's plug this into our calculator. Clear that. 400 minus 40x. Put it in parentheses. Open parentheses. $1.50 plus 0.10x. That's the equation we said, yes?
Yep.
What new command did I just say to you allows you to see things a little bit better on the calculator? Zoom what?
0.
Zoom 0, which was zoom fit. Okay? So I see a parabola open upside down. Now let's adjust our window. Okay? Let's adjust our window. Negative 10 sounds good. Let's see. I don't really need to go out to 100 in the x direction, I don't think. I mean, that's out to 100. If I come back here, come back in a little bit more, we might be able to see a little bit. So let's change our window here, I don't know, to maybe 20. And let's just see what that looks like. Okay, that's just a little brief description of it. Let's take a look at our window. My Y minimum, negative 41,400. Nah. Let's change that to, I don't know, negative 10. And graph it. Is that a pretty darn good looking picture of our parabola?
Yes, sir.
It looks a heck of a lot different than if I had a Y minimum of negative 41,000. Agreed? So if I'm going to look at this vertex, yes, it is shifted back a smidge, but if I do this, let's do this. I'm going to change my Y equals real quick. I'm going to change this to a plus, and I'm going to change this to a minus. Okay? It's one of my equations. Let's see if that's going to give me the same thing. There we go. Okay, all I did is I flip-flopped my signs. I changed my sign from finding, I just made this a plus, that a minus. If I made that a minus, that means I lowered my price 10 cents. Yes? If I changed that to a plus, that means I had 40 more customers. Yes? I wanted my vertex to be on the right side. So all I did is I just changed my information to say, was it better that I increase the price by 10 or lower the price by 10? I wanted my vertex on the right side of the y-axis. Graph looks good. So I can calculate a maximum. So this is our price point. If we sell our coffee for $2.50 a cup, which is $1 more than what they were saying. Agreed?
Yeah.
Yeah.
we maximize our revenue to $625.
Ooh.
Okay?
That's big money there.
Okay? Well, it's not that much, but what is 600 divided by 625? Just tell me on the calculator. 600 divided by 625. 600 divided by 625.
0.96.
I'll get
0.96?
0.96. Yep.
Wow. 4% gain?
The pizza was big.
Would your company like a 4% gain?
I think so.
I think that'd be quite nice.
And you're saving money using
A bit
less
more, but that's what
resources.
Thank you. That is big picture right there. Say that one more time, please.
Come on.
Well, you're saving money because you're serving less customers.
So, you think about this. If you were to sell your coffee for $2.50 a cup, you are maximizing your profits at $625. If you're doing that, that means you're serving less customers. So now, rather than having 6 baristas, maybe you could deal with 5
4.
or 4. You're dealing with less people that you have to work, and you are using your equipment less because you have less product going out. So you have a lot of maximized gains. Okay? Are people walking away going, "Oh man, I'm not going to pay $1 more for a cup of coffee"? Yes. But with the status that they're doing, this is what an actuarial scientist is going to walk through and do. So both of that should help you to figure out the rest of Q, which we'll go over tomorrow. Let's look at notes.
Mr. Stirrup,
Yeah.
what type of music do you like to listen to?
You like
Yes.
Nirvana?
You like
Pearl
This is
Jam?
my favorite band. Huh? Oh, I didn't quite listen. I'm so sorry. Thank
Are you
you.
a big music man?
He likes Led Zeppelin.
Zeppelin's fine.
What do you
Wait,
like?
so what homework is
I should listen to
So like in the car, what do you listen to on the radio or in your phone?
So when I'm working out, I usually have a.
Sandstorm.
No, I don't listen to NWA.
Did you listen to
Green Day, I do like.
Who are you?
So
Yeah,
continue. Who do you listen to when you work out?
Play my team.
Green Bay?
I liked
Day?
Green Day when I was
Green Day.
emo and
Green Day.
Dude, we all emo on the inside, man.
Wait, so what homeworks are due? 5P?
Mr. Stirrup, what do you listen to?
We're out.
So Kiss, AC/DC, Bon Jovi, Guns N' Roses.
Get on that. You okay?
Aerosmith sometimes, not my fave.
Is there any good September?
Except like this.
Def Leppard sometimes.
Do it for next year's. No,
All right,
No, they don't.
this is gonna make a few of you feel a lot better. Okay, so we're just gonna start talking about domain and range. We have a way of doing it that's pretty simplistic. Domain deals with the x values. Okay. We also call the x values as inputs. Is that okay? That's your horizontal axis. Agreed?
I know.
You're good?
Well, okay.
So on our xy axis, that's going to be our domain.
Okay.
Good so far?
Yes.
Any part of that just didn't make sense.
No.
Okay, it's not going to get much harder than that. Now we're going to talk about our range. Our range are our y values. We also call them output. Okay? These are just terms that are used. Our domain and our range, this is our range.
Okay.
Seem okay so far?
Yes.
The y-intercept is 0, something, meaning you'll plug 0 in for whatever x values. What it'll give you as an answer will be the y-intercept. Sound good? The x-intercept will be blank, 0, meaning I plug 0 in for y. Okay? As far as parabolas go, you only have one. That happens here. On the x-intercept, I have 1 or 2, depending upon the parabola. And then we also found out in the last section, we can have ones that are complex so they don't even cross the x-axis. Agreed? And then we have to review something called interval notation. So interval notation looks something like this, where we have some number, and then we could have some number to infinity. These brackets can be square as well. If they're square, that means you include the point. If they're rounded, that means you go up to the point. Okay? I think you've all heard about interval notation at some point, probably 2 years ago.
I understand.
I feel like we did this.
Good.
I haven't I've never heard about it until this class. But
That was like a unit now for one.
All right. It is. All right. So, let's,
Wait, could you go back for just a second?
yeah.
last year was irrelevant.
Wait, so
All right.
Yeah, geometry's lame, man.
I love geometry. All right, so let's talk about the domain of this parabola. So far you have up there things you can tell me. This is a parabola that opens up. That means I have some sort of x squared value. It's a positive x squared value. Yes? Any part of that you're like, I'm not sure. So the domain, we're going to write along the x-axis. So this arrow is pointing and going forever. So it's also going forever this way. This arrow is pointing forever here, so it's also going forever that way. Make sense? So my domain of this particular parabola, just by looking at the picture, because I have arrows at both ends, I'm going to have negative infinity to positive infinity. So I can go forever to the right and forever to the left. I can plug numbers in and I can get a number out. That's all it means. Pretty simple?
yeah.
The nice thing is the domain on pretty much all parabolas, unless we restrict it because we have a word problem, will go from negative to positive infinity. And we'll talk about restricting things in a little bit. Okay, the range is like an elevator. Okay, so I'm on the y-axis. I'm way down at negative infinity. Okay, I know we can't get there, but let's just pretend. So I'm riding this elevator up. So let's do this. Let's do a star. Okay, I'm going to use my star. Okay, ready? This star is my elevator. Tell me when this top point touches the graph. This top point right here. Tell me when it touches the graph. Ready? I'm riding up the y-axis. You still with me? Tell me when my star hits the parabola.
Yeah.
Okay, so what is that y value right there?
-4.
-4. This graph does indeed exist at -4. So my range is going to be square bracket -4, and that elevator ride will go up to infinity. And infinity always has rounded brackets because we approach it, but we can't get to it. Good so far?
Yeah.
Is that star an okay elevator? Like, where do we have star elevators? I don't know, Disney World or something. All right, my roots. I have -2 and +2. What do you mean by that? Well, it's where it crosses the x-axis. The vertex appears to be at 0, 4.
-4.
Thank you. -4. So my roots are x equals +2 and -2. The equation for the axis of symmetry. The axis of symmetry is the simplest line in the world to deal with on a parabola, but is always forgotten. What is the x component of my vertex?
X equals 0.
Done. There's my axis of symmetry. X equals that. X equals 0. This is called the axis of symmetry. This is the line of symmetry that my parabola folds over on top of. It's a vertical line. X equals a number is always vertical. Has an undefined slope. Now, this might be the newest thing possible. Highlighter, we'll go yellow. Interval where this is increasing. So, that's where this is increasing. You see that yellow up there? Okay, so using the x-axis, where does my graph start increasing? Using what's going on in the x direction, what number starts it at the increasing?
0.
0. Awesome.
2.
So it's increasing from 0, and it's going to go forever right. So 0 to infinity is where my graph will be increasing. Okay, I'm using my x-axis to tell me where my graph's increasing. Agreed? All right, so then let's go the other way. We're going to go highlighter, and we're going to go blue. The interval where it's decreasing.
-infinity to 0.
Good, you read that right. So you read to the left to right. You read left to right, so from -infinity all the way to 0. It's a rounded bracket at 0 because right at 0, it's not increasing or decreasing. It's constant. Okay? That's today's lecture for the most part. Okay, there wasn't anything else down there? Sweet. Okay? 0 is where our line starts changing direction. It goes from decreasing to increasing or increasing to decreasing. It's called a critical value. That's the vertex in this case. All right? Can we try one more?
Sure.
I guess.
All right.
You sound so apathetic, my dude.
Negative
This-
infinity
Oh my God,
to-
use
This parabola opens down. So my domain is indeed negative to positive infinity. It goes forever left, forever right. My range, where does it appear it starts? Where is it coming from? If I ride the elevator up, I come from negative infinity, and I'm going to get all the way up to 1. Square bracket. Done. Is our vertex a minimum or a maximum? Max? I guess I have to go back. Did I ask us on this last one? What's our vertex here? Minimum or max?
Minimum.
Minimum. Okay? Sorry about that.
It's minimum down max, right?
Yep. Roots. Where does it appear it's crossing the x-axis?
-4, -2.
X equals -4 and -2. Love it. Vertex appears to be where?
One, negative 3.
Negative 3.
1.
What's my axis of symmetry?
Negative 3.
So it's x equals -3. Good so far?
No.
All right, so now we're going to look for increasing, decreasing. Where is this thing increasing? Increasing's doing right here. It's going up, yes? So where's it increasing?
Negative infinity to -3.
-3. Rounded brackets on both, because at -3 it's constant. Where does it appear it's decreasing?
-3.
-3 to positive.
That's it. Love it.
I feel like we've done this, like, in math.
Okay. You must have had a good math teacher before. Those of you who had me in earlier years, you probably are getting lost. All right. Parabola opens up. Domain.
0.
Negative to positive infinity. Range goes from 0 to infinity. Agreed? Max or min? Min. Roots.
0, 0. None.
There's 1.
0, 3.
So x equals -3. Agreed? And we should say it's a double root, but it's not vital. My vertex is also at 0, or excuse me, is at -3, 0. The axis of symmetry is x equals -3. It is increasing from -3 to infinity. It is decreasing from negative infinity to -3.
We're killing it.
Dude, did I get done? Or is there more? How much?
One more.
One more?
There's 4, 5 more.
Holy shnikes. All right, we good? Can I move on?
I feel like a person who is really bad at math would call the axis.
All right. The graph shows the model of the height of a platform, a diver, as the function of the distance of the diver to the edge of the platform. What is the y-intercept?
0, -10.
0 what? 0, 10. What does that mean in the context of this problem? Height of what? The diving board. Diving board, diving height, or something like that. Okay, it's the platform this person was standing on. What is the greatest height that what is the greatest height this guy gets to? 12. So he jumped upward, right? So 12 meters is the tallest height. Which of the x-intercepts has meaning in this problem? The one in the negative area or the positive? Positive. Okay, so this one means something. 3.5 comma 0 means what?
That's when he hits the water.
Yeah, actually they have that distance in meters, so he went out 3.5 meters away from the diving board. 3.5 meters, I don't know, from here to the wall roughly. I'm guesstimating. Not being perfect, maybe here to that wall. Okay? Can I move on?
Yeah.
Yeah, buddy. All right, quick review. Let's do this one in blue. 5, negative 4. Pattern graph, right one up 2, left one up 2. And I can keep going. I can go right one up 6. Left one up 6. There's that one. Agreed? Let's do this one in red. So I'm going to do negative b over 2a to get my x component of my vertex. You still with me? So that's negative 8 over 2. So negative 4 comma something's my vertex. Let's see if I plug that in. I get 16 minus 32 plus 8. That's 24. So that's negative 8. Negative 4, negative 8. No tripping. Pattern graph, right one up 1, left one up 1, right one up 3. 1, 2, 3. Left one up 3. I guess I could go right one up 5. Left one up 5. And then this one in green. Hang on, don't leave yet. I still got time. Where's that cross the x-axis?
6 and negative 2.
6 and negative 2. What is halfway between 6 and negative 2? 2. So my vertex is going to be at 2 comma something. Okay, because that's halfway between those 2 points. Okay, so if I plug 2 in, 2 minus 6, negative 4. I'm going to do half of that eventually. And then 2 plus 2 is 4. So negative 16, half of that's negative 8. So 2, negative 8. Pattern graph, right 2 up 1, left 2 up 1. Why did you do right 2, left 2? Because it's fatter. Okay, it's easier to do that than to go right 1 up half. Okay, did I get done? You guys are like all packed up and.
Yeah, you're done.
No, I'm not. We got there. Okay, standard FOIL out. Factor. Is that okay? Can I go quick? I still got time. I don't know why y'all thought it was time to go. Not done. This one. Complete square. Factor out. Last one. Standard, FOIL, or double distribute. Complete square. Done. All right, so, guys and girls, tomorrow I need worksheet Q tomorrow. You have enough to finish it, and I think, if I did this right,
I don't know how anyone would
QR. QR. And then worksheet R. Both of those are due tomorrow. Got it?
He was,
Get out of here, guys, girls. Have a great day.
he was due today, so I can turn that in tomorrow.
honorary.